Our first speaker is Justin Ray. Justin is from the Department of Biological Sciences, and the title of his talk is Who Goes There? Pathogen Recognition in Plants.
You know, to be honest, I've been better. I got a little sick last night. I got a little sore throat, scratchy throat. So I'm just kind of like fingers crossed I don't lose my voice, to be honest with you. But otherwise, nerves are fine. They're going to be there, but I'm good otherwise. Yeah.
Worldwide, over 9,000 plant species are affected by powdery mildew infection. Powdery mildews collectively account for more crop loss than any other plant disease on earth. Plant disease is a problem, and a growing one at that. We need food. We all need food. No matter what disease any of you may acquire throughout your lives, you're always going to need food. And with population estimates reaching between 9 and 10 billion people by the year 2050, this food is becoming increasingly important. Not only do we have to feed this many people, but these people have to have a place to live, land to develop, etc. This increase in land consumption is naturally going to result in a decrease in available farmland, meaning we must make the most out of the current food crops that we have available. Powdery mildew affects a wide variety of food crops, pretty much indiscriminately. It affects economically and nutritionally important food crops such as corn, soy, wheat, and rice, just to name a few. Powdery mildew can account for up to a 40% crop loss from the time the plant germinates until it reaches our homes, with a lot of this loss occurring in transit or in storage. If dollar signs help to grab your attention, it was recently reported by UC Davis that generation of a powdery mildew-resistant grape could save the state of California over $48 million annually in the wine market alone. In our lab, we focus on unraveling the cellular pathways associated with the plant's natural ability to defend itself against fungal pathogens, or plant innate immunity, as we call it. Above, you will see an image of the devastating effects powdery mildew can have on cucumber. In our lab, we actually use cucumber to cultivate the pathogen and then infect our model plant Arabidopsis thaliana for study. Arabidopsis is useful as a model organism because of its quick growth rate and of its relative similarity to other higher plant species. We've identified a family of genes that we believe to be important in plant innate immunity to fungal pathogens. One of these genes has shown particular prominence in our preliminary studies. You will notice above that when this gene's function is removed, the plant shows an increase in susceptibility to the pathogen. However, when we increase this gene's function, you will notice a marked resistance to the powdery mildew. We hope to implement current genetic techniques like this to make not only Arabidopsis more resistant to powdery mildew, but also other economically and nutritionally relevant crop species across the globe. Thank you.
Thank you very much, Justin.